All right, so everyone in here knows the square root of 9 is what? 3. Guys, you're so smart. Who knows what the square root of negative 9 is? Michael? Yeah, 3i. That imaginary unit comes out. When we have a negative under the radical sign, to figure out the answer, we pull the letter I out. It represents the imaginary unit. A French mathematician, I think it was Rene Descartes started this stuff so we could figure out square root of negatives. So this is what you need to know about the I and the square root of negative 1. Those two equations there you should know. The square root of negative 1 equals I, and then I squared, if that shows up in a problem, you should know that it equals negative 1. So if I have like 5 times I squared, or 5I squared, I should change it to negative 5, because it's 5 times negative 1. Okay? So we have to remember that. We learned that last year in Algebra 2. That should be reviewed for you. So we're going to simplify some radicals first. So how do we simplify a radical? Do we just put it in our calculator? Or do we have to do something? We don't put it on a calculator, so we do have to do something. T and T. What do you think? Remember what we did? Did we do any radicals yet this year? Simplify? Yes? No? Maybe? Oh, that was my other class. Algebra 2 is not. You remember? James, what were you going to say? Yeah. Do a factor tree, right? We'll do a little factor tree. And you can use whatever you want. You know, that works. You know, 15 and 10 or 75 and 2, whatever. But I like to try to figure out in my head when I write it down some perfect squares that are in there. And I know 25 is a perfect square. And I know it goes into 150 6 times. So what I like to do when I see a perfect square show up, I like to circle it. That reminds me I have to do what then? When I circle it, it reminds me I have to remember to do what? Well, what are we doing here? What's this symbol? Square root. That's the square root. Okay, what is the square root of 25? 5. So I can bring a 5 out front. Since it's negative, what else do I have to bring out front? The I, we just talked about. Now this is 2 times 3, but are either 2 or 3 perfect squares? No. So I have to still, I can't just forget about that 6. So I just leave it under that radical sign. So that's what it simplifies to. 5i radical 6. Okay, coming back to you a little bit. Ashton, you all right? Band seniors had a good show Friday night. Yeah. Did a good job. All right, so we're good so far. Makes sense? Simple, right? Okay, what about something like this? Whoa. All right. Is there anything I can simplify there, or is that just it? Can I simplify that right? Negative 45? Mm-hmm. Yeah, I would do 9 and 5. Yeah. Why is this thing jumping around now? And 9's a nice number. I like it because it's a perfect square. So what can I pull out? 3, right? So the 3, and since it was negative, also the I, and then the 5 will stay underneath. So that's all we can do. We can't do anything else. These two things aren't like terms, so I can't, make it 10i or anything like that. In order for me to add those two, it'd have to be 7i radical 5 plus 3i radical 5 in order for me to be able to add them. With multiplication, I could multiply, but addition, subtraction, like terms, like radicals, all that stuff. Okay? You guys try this one, please. See how you do. Did I, Ashton, was it you that was gonna be electrical or getting the electrician field? There was somebody else too, I forget who it was. Oh, okay. Kenny, Keith. Come back, take my spot. Are you math teacher? Maybe. Cool. Take over from me and become a lesson. People. Easy switch. Can't remember what you said, Michael, when you were gonna do psychology. When you get it. Rough Monday. What's up? Rough Monday. I'm here. Well, that's good. Okay, you're doing the perfect square, Chris? Write it down again.
That's next. For what? So one. Yeah. Yeah.
Good, now. 2. 4, 5, and 2. No, that's what comes out from the red. No. 3 is right. All right, guys are doing good. Again, I've seen different things, 30 times 10 and 2 times 150 and 6 times 50 and 5 times 60, but I like this one. Why do I like that one? Because that's a perfect square, right? Okay, maybe somebody did 25 times 12. Okay, that's okay too. Any of those are okay. All right, but I like to try to find the biggest perfect square in there, so I have less numbers to put down. So the square root of 100 is 10. And then since it was negative, don't forget the I, and then the 3's left, so that stays under the radical sign. But if you went all the way down, to all the prime factors, it'd be 2 times 2 times 3 times 5 times 5, if you had them in order from littlest to biggest. So if you see a pair of 2's, what can you pull out? A 2. If you see a pair of 5's, what can you pull out? The 5. You multiply those, whatever you pull out, you multiply together. So 2 times 5 will give you the what? The 10. So again, it doesn't matter how you start your factor tree, you still end up, you should end up with the same answer. Make sense? Any questions? Okay. Let's look at another type of problem we're going to see. I'm going to add 2 of these. Oh, you know what, we didn't talk about that, when it kind of jumped on me, we forgot to say what, this is what a complex number is. It's A plus BI, okay? So this is a complex number we got here. The part in front here, without the variable and the i's and stuff, is called the real part. And this part in front of the I we call the imaginary part. So sometimes they might ask you what part's what, just so you know. But that's the basic look of a complex number. So we got two complex numbers here, and I'm adding them. Mr. Myers, what do you think we get when we add them? William, can you help him out?
5. Oh, you want to explain?
Close. Just 5 plus 2i. Just combine like terms, just like if it was x's or y.
Oh, okay.
Okay? Don't overthink it. Just 7 plus negative 2, negative 2i plus 4i. Just combine like terms. Constants and i's, imaginary. Okay? Nick? This one? 11, close. 11 plus. But look, it's negative 9 minus 2, so it's negative 1. Negative 1, yeah. Plus 10i. Good. Minus a negative 6i is plus 6i. So it's 4 plus 6i is what we're doing there. Minus a negative. Don't forget that little detail. Minus a negative. Okay? Easy. Those are really easy, adding the two complex numbers. Okay, Haas? Robinson, what do you think? 15. Close. 15. I. Like what's x times x? X squared. I squared, yeah. So treat it just like it was an x. But when we learn or talk about, remind ourselves I squared equals negative 1. So this is 15 times negative 1. So our answer is actually negative 15. Okay? So if you had me last year, here's what I would do when I saw this I squared. I always just cross it out and change the sign of whatever, of what it is in front. If it's addition, I change the subtraction. If it's subtraction, I change the addition. Okay? So when I see an I squared after a number, that's what I do. I cross it out and change the sign in front of it. So if you understand that, you like that, you can go ahead and do it. If you want to write it 15 times negative 1, that's okay too. All right? Got one more down here. Sydney, what do you think we should do there? Right. So go ahead.
You did 12i minus 8i squared.
Good. So can we go a little further then?
Cross out the I squared and change the sign in front of the
All right, good. So 12i plus 8. If you want to get technical, some mathematician might want you to write it in the right order, but I'm not going to, if you have either way, 12i plus 8 or 8 plus 12i, I'll give you full credit. But that's what they like us to do, is put it in the right order. Okay, so far so good? Good job. Pretty easy so far, isn't it? Okay, a little bit more thinking here, this second one. Second slide. Okay, this first one here. What do you guys think? Go ahead and try that. See how you do. Think about Aunt Sally. Let me do this problem. Okay, so that's good. What happens with that? If it was 4, -4 would I? So you're close. Okay, we'll plug it together. Because it was. Yeah, put it across. Yeah, that's all. There you go. I'm gonna get that. Mm-hmm. All right, that's good. Yeah, so far. Okay. So now 4 is 2. Okay. Yeah, okay. So this is negative. So we pull out. Well, yeah. So I'm going to see. I'm just finding all about that. Okay, good. Like that. I'm on the bottom paper. Yeah, do that first, do the back. How you doing back there? Yeah, that's a lot of people think. Actually, I think it's fine. We'll put together and simplify. All right, you guys are doing good. Good try. A lot of kids will just multiply. What's -2 times -8? Positive 16, and what's the square root of 16? 4. But that's really not correct. You know, we think about order of operations. It's please for parentheses, excuse for exponents. Well, radicals are like exponents, right? I can rewrite this radical with an exponent. You know, it's -2 to the 1/2 power times -8 to the 1/2 power. So I have to do exponents next. That means I got to simplify them first. So the first thing we do for the first one there is take the I out, because it was negative. And then this one, and most of you are doing this, you know, you do your factor tree for the 8. So that's a perfect square. So remember, I'm taking the square root of 4, which would be 2, and then it was negative, the I, and then the radical 2. So it looks like that after I simplified those negatives and that 8. Now I can multiply. So 1I times 2I is 2I squared, and radical 2 times radical 2 is radical 4. So it looks like that. If I'm showing all the work. And some of you can do this a little quicker than showing it because you can do some of this in your head. But I got my 2. And then what does that equal? Negative 1, right? What's the square root of 4? 2. So actually the answer should be negative 4. Okay? If you're following the rules of operation, like you're supposed to. So simplify radicals first before you multiply or divide them or add or subtract them, right? Okay? You guys try this one, please. Oh, you tried that last one too, didn't you? Since you tried that last one, I'll just go ahead and do this one. Can I simplify either one of those radical 3's? Do I need to pull anything out? No, so it's already basically at this point, right here, right? Just multiply. So I got I times 2I, another 2I squared. But this time, 3 times 3 is 9, so this would be 2 times negative 1 times 3. So that comes out to negative 6. Does that one make sense? Those are pretty similar. Okay, so far so good? Okay. Mr. Wallace, you had a couple good runs Friday. What do you think about this problem? Yes, spoil it. Okay, now here's what happens. We're foiling it because what type of problem is it? Multiplication. All right, so once I show students this, foiling, when they see these two, they want to try to foil. You see the difference? These two don't have to foil. Why? Addition and subtraction in between them, right? It's combined like terms. Okay? But you do have to FOIL when it's multiplication. Okay? So FOIL is first. So that's 3 times 2. So that's 6. O is for the outside 2. That's 3 times 5i, which is 15i. I is for the inside 2. That's negative 4i times 2, which is negative 8i. And L is for last 2, which are these two. The negative 4i times the positive 5i is negative 20i squared. Okay, don't forget about its I squared on that last one when you're multiplying two complex numbers. So what can I do with that negative 20i squared? Make it positive 20, right? Because I squared is negative 1. So it's like negative 20 times negative 1 or positive 20. So now I can combine like terms. 6 plus 20 is 26. And 15i minus 8i will be positive 7i. Okay? Make sense? Foiling is pretty easy, right, Ashton? Okay. So, you guys try one more for me, then I'll give you your assignment. Do that problem, please. Huh? You guys got the email? Who we find? Here or there?
Yes, I'm quite a few here around, you know. That pot. What?
Think about simplifying first before you FOIL.
So, I think you're on. What?
Yeah, yeah.
Horse related. Horse related.
All right, you guys are doing good. You guys are working hard today. Nice job. Let's, remember, do what's in parentheses first. I can simplify inside each parenthesis by pulling out the I for both radicals. Nothing else, because 3 is prime. So it should look like that when you start. So don't FOIL right away. Pull out the I, because they were negative radicals. Now you got your 2 times 4, which a lot of you had the 8. And then 2 times negative 5i radical 3 is negative 10i radical 3. And then I radical 3 times 4 is 4i radical 3. And then last is I radical 3 times negative 5i radical 3 is negative 5i squared radical 9 if I write it out. Most of you, once you start doing these, you realize that that is a 3, and then you're just going to go make that a negative 15i squared, which turns into what? Three times negative 1 times negative 5 is positive 15. You guys follow me on that? So combine like terms then. 8 plus 15, 23. Negative 10i radical 3 plus 4i radical 3, they're like terms, so that's negative 6i radical 3. So that's the toughest type of problem you'll have, where you'll have to simplify first before you multiply or FOIL them. Okay? Remember, when you see addition or subtraction between the 2 parentheses, just combine like terms. You do not have to FOIL. All right? It's just the multiplication that we have to FOIL. There's your assignment. There's about 10 minutes. You can get some of it done. first few go pretty quick.